So here we are, chapter 3 of our night book, the green book with the grasshopper on the front. We are going to start on number 50 in this chapter, which is another vector problem, solving vectors, adding components, and things like that. So it starts by reading, a pilot in a small plane encounters shifting winds. He flies 26 kilometers northeast, then 45 kilometers due north. From this point he flies an additional distance in an unknown direction, only to find himself at a small airstrip that his map shows to be 70 kilometers due north of his starting point. What were the length and direction of the third leg of his trip? So you can see I drew a little sketch of his path, right? A, B, C, and then the resultant. And then I wrote down the given information. All right, B and the resultant, they told us they were north, so I took that to be 90 degrees. A was a little tricky. It was kind of maybe a little cheap because they just say northeast, and they want you to assume, without telling you or giving you any sort of indication, that northeast should be 45 degrees. But such is life, and we'll go with it and see what we can come up with. So to find this unknown vector C, we're gonna take these things and they're at angles again, but life is easy if we take these angles and we make them into vertical and horizontal components. So that's what we're going to do. We're going to look at the x components, we're going to look at the y components, and then see if we can combine them. So looking at these components, we know that r sub x, the x component of the resultant up there, should be the combination of a sub x, b sub x, and c sub x. Right, and when we do that, if we look at r, we see that it has no x component because it is completely vertical. But a sub x is going to be equal to that a cosine theta, and then b sub x will also be 0 again because it is 100% vertical, and then c sub x, which we don't know. So c sub x is going to be equal to the component of the a vector, and it'll be the negative of that because we can subtract this over to the other side. So we'll get then a has a magnitude of 26 and it's at a angle of 45 degrees. So we find that that c component is going to have a magnitude in the x direction of negative 18.4 kilometers. Right? So then if we do the same to find the y component, we know that the y component of the resultant is the sum of the components that make up that trip. So r sub y is going to be equal to a sub y plus b sub y plus c sub y. We know then that r sub y is 70, a sub y is a sine theta, right? B sub y is 45, and c sub y is that one that we don't know. So solving for c sub y, we find that c sub y is going to be 25 minus a sub y, or the a sine theta, which is going to be 26 sine of 45. And we then get solving that c sub y is going to have a magnitude, right, the y component of c, of 6.62 kilometers. And that kind of matches up. If you look at now c sub y, right, it's got components, a positive y component, but a negative x component, which agrees here with what we've got for answers, or what we've got for components over there. All right. So now, if we're going to actually find what C is, we need to resolve these two components. And again, if we look here, we get a nice right triangle. If we kind of imagine we drag the y component over here, it makes a nice right triangle. So if we're going to find the magnitude of this vector, all we have to do, again, is use the Pythagorean theorem. So C is going to be equal to the square root of negative 18.4 squared plus 6.62 squared. And we get that C is going to have a magnitude of 19.6 kilometers. And then to find that direction, right, it is the inverse tangent of y over x, so 6.62 divided by negative 18.4. And we find then that theta will end up being negative 19.8 degrees. All right, that is the angle right here. So in order to find that angle from the positive x-axis, or what we consider to be 0, we're just going to take that 180 minus that number, right, or 180 plus that number, however you want to think about it, and it's going to end up being 160.2 degrees. So to wrap it all up, we find that vector c, if this pilot's going to fly this path and end up 70 kilometers north of where they started, vector c is going to need to be 19.6 kilometers at an angle of 160.2 degrees. All right, so that was chapter 3, problem number 50.